So the purpose of this video is to show the 6 steps as I have reworked them from physics classroom to work through problems dealing with acceleration equations and those 4 main equations that we've discussed in prior videos. The 6 steps are as follows here. Step 1 would be sketch a picture. Step 2, very, very annoying to draw, but do it. Step 3, fill in the very, very annoying to draw table. Step 4, use the table. Unknowns. There's a typo there. Unknowns to determine right, and then write equation. That's not a mistake. The right equation, and then you need to write the equation. Substitute in knowns into equation and then solve. Confirm solution works with equation and seems logical. And so obviously this calls for an example and exactly what is this very, very annoying to draw thing, but do it. And so we'll sort of work through an example and I'll give you some more details of that. So we could start with a really basic question like this. This is the kind of thing we would see. A person at a stoplight races off when the light turns green. After 1 second, they've traveled 80 meters. So if we go back here and we try to model through this, step 1, sketch a picture. This doesn't necessarily need to be anything fancy. It's mostly just the idea is to kind of get you thinking about what's happening. You draw a little car, think of them racing off. This was 1 second later. You could say 80 meters. 1 second later, and then we could say, well, they also, they were stopped. All of these things are important. They would be stopped. So this is the example of step 1. Step 2 is the most important thing, in my humble opinion, and that's this thing called very, very annoying to draw, but do it. And to do that, you need to draw 3 vertical lines and 5 horizontal lines. So what that looks like is 1, 2, 3. Let me do this. We can see we need to fix this a little bit. This doesn't have to be anything fancy. I do have a beautiful one printed out that I'll show you in a second. But if you were doing this, this could just be a really crude, quick sketch. Now, what's up with this very, very, very annoying to draw, but do it? V, V, A, T, D. This is a big deal. V, V, A, T, D. Let me back this out a little bit so we can see a little bit more. What we mean by that is V, V, A, T, D. Very, very annoying to draw. There we have it. Now, what goes across this top line? This is the symbol. Number. This is the given unit. And then, pretty sloppy here. Then this is the SI unit. When you look at your numbers and when you look at your story, you can think about this. Person at a stoplight races off. And we think about our picture there. What do we know? What do we know? Well, we know that displacement is 80. I'll go with blue for clarity's sake. We know our displacement is 80. What's the unit, the given unit? Well, it's in meters. And then we want to think, what's the SI unit? Well, we know that's meters. Remember from before we had a table where we had those SI units. What else do we know? Well, we know time. That was 1 second. And the SI unit is second. And then we have, what's up with these 2 V's? Originally, when we did very, very annoying to draw, I should have put initial and final. My guess is you'll forget that too. But you know, one's initial and one's final. We don't really know acceleration. Question mark. We don't really know velocity final. but we do know velocity initial because it was stopped, and so we could say it's 0. Now, this is important because for step 2, it shows us what we know, this, this, and this, and what we don't know, this and this. And if we remember, if we go back to when we introduced those 4 equations, with those 4 equations, every equation has 4 variables. To solve it in one step, you need 3 of those 4. And so we actually have 3 variables here. So we could solve for either one of these we needed, depending on which equation we choose. Now let's say, for purpose of example, let's say that we want to solve for velocity final. We're going to solve for that one. So what we do is we have those 4 equations that we had from before, those 4 equations, and we're going to look for one that has basically doesn't have acceleration, because that's the one we don't care about. And this one has acceleration, so we don't want this one, throw it away. This one has acceleration, so throw it away. This one has acceleration, so we'll throw it away. And this isn't one of the 4 main equations because I picked up the wrong paper. And, oh, check this out. Check this out. We have displacement, check. Velocity initial, check. Velocity final, unknown. Time, check. So we have 3 of the 4, so we can actually solve for this. Okay? So we know this is going to be our equation, and what we just actually did right there, what we just did was step 3, fill in very, very annoying to draw table. We filled that in. That was actually step 3, doing this. Step 4, use the very, very annoying to draw unknown to determine right equation. That's where we're at right now. Now we're ready to write the equation. So the next step is going to be to write that. I'm going to pause this so you don't see me taking the time. Okay, so I just documented that we did in fact do step 3, and then in step 4, remember the second part of step 4 was to write the equation. So in fact, I wrote the equation. Now, step 5 says substitute knowns. Step 5, again a typo, substitute knowns into equation and then solve. So what we do is we put in what we know. So we know from up here that displacement is 80. Let me change the color here. 80 equals velocity initial of 0 plus velocity final over 2 times t. What is t? That's a value of 1. Then we can continue to work this. $80 equals VF over 2 times 1. That cancels out, so we're just left with that. Now we're going to multiply both sides by 2. Get this out from under it, times 2. And this side times 2. And we would find that, in fact, 160 equals VF. So velocity final would be 160. We can put that up here. And then we need to think, did we start out with SI units? Seconds in meters. This was seconds in meters, yeah. So what's our SI unit for velocity final? That would be meters per second. And so in fact, we could say 160 meters per second equals velocity final. Now, that's step 4. What do we have here for step 5? I'm sorry, that was step 5 we were doing. Step 4 was the equation. I'm so sorry, I should have shown that. Step 5, I think I said it, but I didn't show it on there. That's step 5. Now we're on to step 6. Confirm solution works with equation and seems logical. So here where we wrote the equation, to start with, does 160 meters per second seem reasonable? If you start at 0 and you're blasting through an intersection and you're getting up to 80 meters in 1 second. Yeah, that seems reasonable to me. Maybe you can't think through and you're not sure if it seems reasonable and logical, but at least think about it. The other thing you can definitely do is you can substitute in what you came up with and make sure it works. So we can start back over here to this, and we can put in what we did. 80 equals 0 plus 160 over 2 times 1. And you can solve this, and you should find, in fact, that 80 equals 80. And so, yes, we did check it, and we're good. That's the final thing for step 6, that the solution works with the equation. Another really good thing to do, I don't know that it's on there, but a good rule of thumb, age-old practice, is to circle your final answer.